Hi there, Math 20-3. So we are going to focus on chapter 1.3, rate of change. So this is something you might have seen a little bit in 10-3. Maybe if you took 10C, this is something you've also seen. It's another way to calculate slope, but this time we're using the graph. Okay, so from last unit, we learned that slope equals rise over run. Well, now we have a new way to determine slope based on a graph, and that is represented as this. Okay, now what does all this mean? Okay, recognize this triangle is just a symbol for a word. So this triangle here just represents change. Okay, so it's the change in y over the change in x, which is exactly what rise over run is. If we think about a graph here, okay, this is the rise, okay, up and down is rise. Run is the horizontal, so the x is the run. So if we change numbers in our y, how does the x change in respect to what the y is changing? So that's called also the rate of change. So slope is known as rate of change as well. Okay, now remember slope also is represented by a little m, okay? And this is normally what the equation we're going to use here. So m equals y2 minus y1 over x2 minus x1. Now what does all this mean? Well, these are coordinate points. Now remember, coordinate points are points on the graph. This is a coordinate point here. And remember, coordinate points are represented by this. So this is a coordinate point. You have x and y, okay? Now, your coordinate points are found on your graph. This would be a coordinate point where your x is 4 and your y is 4. So this is a 4 and 4. This is the x, this is the y, okay? Now, you have to find 2 points on your graph and plug it into this formula. This would be one coordinate point, x2 and y2, x2, y2. The other coordinate point would be there, x1, y1. We plug that in, okay? We could use any of these points and plug it into this formula. So let's kind of check out some things. Now, you can either have a positive slope or a negative slope, okay? So you will have positive slopes and you will have negative slopes. Now, it's not super hard to remember. A positive slope is something that goes up as you move to the right. So this would have a positive slope. As it moves to the right, you're going upwards. This also has a positive slope. This bottom one would have a negative slope. We are going down as it goes to the right. So this one has a negative slope, which is nice to understand and know, okay? That means if we actually calculated these, we would have a negative number. So let's look here. We have 2 coordinate points on this graph. This coordinate point, remember coordinate points are x and then the y value. This one, your x value is 0 while your y value is 10. So this is 0 and 10. This point here, you have a x value. This would be 9, right? If this is 5, this is 6, 7, 8, 9. So when our x value is 9, our y value is 5. So this coordinate point would be 9 and 5. Now, in order to figure out what the slope of this is, we have to use our equation. Slope equals rise over run. And when we're using it in terms of a graph, we are going to use it where it's x, or sorry, y is going to go on the top. Remember, y is our rise. It's going up and down. So y2 minus y1, and it's really important to line up the proper x value. Since y2 is here, x2 is going to be right below it, minus x1. I don't actually know if this is on your formula sheet. Let's check if it is. It's not specifically on your formula sheet, but it is tied to this, okay? So on your formula sheet, you might want to write m also equals y2 minus y1 over x2 minus x1, okay? Because that's something you might see in your take-home exams. Now, again, we're back to trying to calculate the slope. Well, let's make this coordinate points. Let's make this x1 and y1. Let's make this x2 and y2, okay? So now we just plug these in our values. So y2 is 10, so I'm going to plug in 10 for y2, minus, and the other y value is 5. So 10 minus 5. So remember, this is y1, this is y2. This 10 is attached to this x coordinate. So this will be 0 below it, minus 9. So this y value is attached to this x value, so it has to be below, and we also represent it as x1. 10 minus 5, now it's really important to keep track of your negative and positive values. I'm going to plug these in our calculator. Don't be scared to use your calculator for everything. Even if you're not, even if you think you know exactly, these signs can trick you up a little bit. So this is positive 5 on the top over 0 minus 9. 0 minus 9 gives me negative 9. So here we have 5 over negative 9. Now you can notice we can also represent this as just negative 5 over 9. So this is the rate of change, and it's a negative, just like we know it's a negative slope, because as we go to the right, we go down. If we were to calculate slopes on these, we would get a positive number. Okay, so that's also known as the rate of change as well. Okay, so this is known as slope or the rate of change. And lastly, it's also represented just simply as m, okay? Now, which one is steeper? What does steeper mean? Okay, the amount of steepness, let's write up here, steepness, okay? So remember, we can plug in our slopes and get a decimal number. So like that last one, like 9 over 5, we could plug that into our calculator. 9 divided by 5, and that gives us 1.8. Okay, something to understand, the bigger the number this is, the bigger the slope is, the steeper it is. So steeper simply means larger slope. So if you're ever asked to calculate or see which value is steeper, so make sure you copy this down, okay? You want to copy everything down I write. This question is asking you which one is steeper here. So we use our slope formulas, okay? I guess they put this as, we have 6 and 9 and 2 and 3 here. So here is our x value 6, and then the top value would be our y value minus 2 and 3 here. So they calculated slope for both of these things. And now remember, the bigger the number, the bigger the slope, the steeper it is. So that means since this 1.5 is a lot bigger than 0.6, L2 would be a lot steeper, okay? Now, let's calculate these slopes here. So these are kind of strange. They're not at an angle. So what happens with that? Okay, well, let's just calculate it as normal. So let's focus on L1 slope. Okay, L1 slope, we're still going to use y2 minus y1 over x2 minus x1. It's always useful to know which one's which, so you can relax your brain and just plug numbers in. So here, let's focus on L1, which is this horizontal line. This coordinate point is at 9. Okay, this is 9 here. The x value is 9 and the y value is 6. So 9 and 6. I'm going to represent this as x1, y1. Okay, so that's going to be x1 and y1. This guy I'm going to represent as x2 and y2. And what is that? Well, this is 2 here, and this is 6. So that will be 2 and 6, and this will be x2, y2. Okay. Now, let's plug these into our formula here. So y2, what did we say y2 was? y2 we represented as 6. So this will be 6 minus, and what was y1? Well, now y1 was 6 here. What was x2? x2 was actually the value 2 here. And what was x1? x1 was 9. Okay, so we can plug these into our calculator. What is 6 minus 6? That is 0. What is 2 minus 9? -7. And now, to figure out the slope, we want to do 0 divided by -0.7. So this equals 0 dividing -0.7. I'm going to put bracket around here. So 0 divided by, and let's do -7. And that gives us 0. So that's kind of interesting. The slope here is 0. What does that mean? Well, if you think about it, when you walk on a straight path, okay, if a little guy was walking on here, would he say there's any slope? No, it's an absolutely horizontal line. It's a horizontal rope. There is no slope. So it's simply a slope of 0. Let's look at L2. So line 2's slope. We're going to do the exact same method. Sorry. Little technical difficulties there. My stand is failing me a little bit. That's okay. There we go. So let's note, I'm going to do this maybe in a different pen here. Sorry about that. My computer's not enjoying what I'm doing right now. There we go. So what is this coordinate point? Well, that is 4 and 2, right? There's 1, 2, 3, 4. Okay, this is 1, 2, 3, 4. So this coordinate value, remember x always goes first, 4 and 2. Okay, I'm going to represent this as x1 and y1. This top one here, well, this is 5, 6, 7, 8, 9, okay? And this will be also at an x value of 4, but the y value is changed to 9. And this will be x2, y2, okay? So x2 and y2, I'm going to rewrite that quickly just because it doesn't look super nice. x2, y2. Doesn't look too much better. Sorry about that. Technical difficulties still. Okay, so now we have some values. We're going to use this exact same equation here. Oh, I will be right back. I just got to get a new battery. There we go. Sorry about that, little delay there. So we have our slope, and that's, remember, y2 minus y1 over x2 minus x1. Well, we've already put values to these. So y2 is 9. Okay, so this is 9 minus, and what was y1? y1 was 2. 9 minus 2. x2, was 4 minus, and x1 was 4. So 9 minus 2, you plug that in your calculator and you're going to get 7. 4 minus 4 is 0. Now, we need to plug this into our calculator, 7 divided by 0. Now, what is going to happen here? 7 dividing 0, you actually cannot divide by 0, okay? So divided by 0, there's an error. When there's an error like that, we call this as undefined, okay? So when you have a perfectly straight graph, just like line 2, it's perfectly straight up and down, okay, vertical, it's an undefined slope. So perfectly vertical slope causes undefined, okay? When you are perfectly horizontal, you have a 0 slope, okay? And the way to think about it is there's 0 slope here. We're not even moving. The word undefined means it's so crazy you can't even define it. Imagine going down a mountain that had this type of slope. You wouldn't, okay? It is unimaginable. It is not even, you can't even define how steep this is. This is 0, this is undefined, okay? So this happens when you have a perfectly horizontal line. Perfectly horizontal line. Okay. So let's keep moving on here. Again, pause it here if you need, copy what you need, and then move on. So you have to know how to draw these graphs. Now, remember that, sorry, this computer's a little old. I am getting a new one pretty quick here, which will be much nicer for these videos. Now, you have to know how to create a graph given a slope. That's not super hard because we know what these values mean. So on the graph below, draw a solid line that passes through point A and has a slope of 6 and 5. The first thing we're going to do here, just to visualize it a little easier, I'm going to put the coordinates for every single one, okay? Just so we can talk a little bit more descriptively about what's going on this graph while we draw. Okay, so we have our graph kind of set up here. Now, starting at point A, it wants us to create a line with a slope of 6 over 5. Remember, slope equals the change in y over the change in x. Okay, that's something we can something we can say. We also know, and this is a little easier, it's just rise over run. Remember, rise is up and down, run is side to side. So in this case, our rise is 6 and our run is 5. So for every 6 units up, we go 5 units right, okay? Because both of them are positive. If one of them was negative, then it might be 6 units down, and that we'll be talking about here. But for every 6 units up, we go 5 units right. So here, starting at A, let's go 6 units up. 1, 2, 3, 4, 5, 6. Now that we've gone 6 units up, we need to go 5 units to the right. So we ended up here, now we gotta go 5 units right. 1, 2, 3, 4, 5. So we can connect this line, and we need it to be solid. And it would look something like that. So this is a line with slope 6 over 5. That's why it's super useful. The rise is 6 units up, 5 units to the right. Now we have something a little different. We need to draw a dotted line, okay? Draw a dotted line that has a slope of negative 3 over 2. In this case, so it's still rise over run, but here it equals negative 3 over 2. Now something to understand about fractions is if you have a negative here, you can decide if you want to apply that negative to the top number or the bottom number. Okay, let's simply make this negative 3 over 2. If you did it the other way, if you did it 3 over negative 2, you're going to get the same answer. But now that we have a negative value on our rise, that means we have to go 3 units down. Okay, that's where that negative comes from. This negative says down. Okay, so for every 3 units down, and this is a positive number for number 2, that means we just go right. Go 2 units right. Okay, so here we start at A again, and we go 3 units down. So 1, 2, 3. And we're going to go 2 units to the right. 1, 2. So we're going to end up here. And that will be a dotted line. Okay, so this has a slope of negative 3 over 2. Again, if we could have also done it as 3 over negative 2, but this is going to read a little different. This is for every 3 units up, we go 2 units to the left because it's negative. We would actually be going off here. So if we started down here, check it out. If we go 3 units up, 1, 2, 3, and then 2 units to the left for that negative, we go 1, 2. Okay, these graphs could extend on forever. We could keep doing that. 1, 2, 3 units up, 1, 2 to the left, but then we're off the graph. Okay, so just understand we can either put the negative value on the top or the negative value on the bottom. Okay. Also remember, if you have a negative value on the top, that means you're going down. Okay. If you have a negative value on the bottom, that means you're going to the left. Okay. So there is your solution for 3. Okay. So sometimes you have to be able to create a function. So that's your rate of change. Okay, we have to understand what independent and dependent variables. This bottom number is always the independent value. It simply means the one that kind of changes on its own, or this value here determines this value. So this value is dependent on this value. So this is the dependent value. Okay, time will always be an independent value. Okay, so that's something to kind of recognize. You have your definitions here, which can be very useful. Now remember, your rate of change, this simply just means slope. Okay, your rate of change can be the rate of how much money you're getting, and it's really important to know when you do slope, what are the units here? In this case, this guy's slope, again, would be rise over run. And now if we look at this, our rise is distance measured in kilometers. So this would be some amount of kilometers for some amount of hours. What is that? Kilometer per hour. This is speed. Okay, so your rate of change can change, or your slope can actually represent really cool things depending on what you're talking about. In this case, it is speed. So let's maybe look at an example that we can do together. So like here, Reggie's starting to practice for a marathon. If he walked 3 kilometers in 30 minutes, what is the average rate in kilometers per hour? Well, here its slope, or its rate of change, remember, slope is also known as rate of change. Kilometers per hour, well, he does 3 kilometers in this 30 minutes is 0.5 an hour. So he does 3 kilometers in 0.5 of an hour. 3 divided by 0.5 equals 6. So that means that's actually 6 kilometers per 1 hour. Okay, 6 kilometers per 1 hour. So that's where they get that from. Let's do a question together. recognize he's also, in this example, we've also been able to set up a really useful cross multiplication and division. If he does not change his pace, how long will it take him to walk 36 kilometers an hour? Well, we're going to put distance here, time here. We know his rate of walking is 6 kilometers per hour, right? We found that out in A. So now we can say, well, I'm going to put distance on the top all the time and then solve for the amount of hours. So it takes him 6 hours to go 36 kilometers. So Janita's car needs repairing, and she borrows $600 from her brother to pay the bill. What a good brother. She repays her brother $40 a week. Write an equation that shows the relationship between how much she owes her brother and how much she pays each week. Okay, so write an equation that shows the relationship between how much she owes her brother and how much she pays per week. Okay, so let's write down some things because this is even confusing me. Okay, I need to write everything out that I understand. So she borrowed $600. So borrowed $600. Okay. She repays her brother $40 per week. So this is actually a rate. Okay, this can represent $40 per week. Okay, so she's paying back $40 every week. So every 1 week. Now, write an equation that shows a relationship between how much she owes her brother and how much she pays each week. So there is actually a really useful thing. We can write this equation. So I'm going to write out variables and explain what these variables mean. So I'm going to write P, and P is going to represent how much remains that she owes her brother. So remaining amount she owes. Okay, I'm going to say W represents the number of weeks that have passed. So weeks that have passed. Okay, so here, P, so what does she owe right now? Well, she owes $600 at the moment. Okay, but every week that passes, she's subtracting $40. We have a rate here. So this is $40 per 1 week. And we can write this W that has passed here. Oh, that was weird. Weeks. So we can use this equation. That's our equation. If we do 2 weeks after 2 weeks, so let's do after 2 weeks. I bet this is going to be number B or something like that. We can plug in our 2 for W because that's the amount of weeks passed. So P equals 600 minus 40 times 2. Well, here that becomes P equaling 600. 40 times 2 is 80. So we get $520. So she still owes $520 after 2 weeks. Okay, so that's how we can write this equation. Anytime you're given this, write it out in simpler form. Okay, just note the things that are important. What do these numbers relate to? Can you find a sort of rate of change anywhere? Make sure you state what these values represent. Okay, because this isn't super helpful. But now that we've went through and showed, well, I can go, oh, P means that, W means that, perfect, okay? This is essentially this sentence, much more simplified. This is this sentence, much more simplified, okay? Simplify these questions for yourself. So graph the information. What is the slope of the line and what does it represent? Okay, so if we want to graph this information, we totally can. Let's do the bottom here as weeks. Okay, and I'm going to do every 2 sections is 1 week. So this is 2, 3 weeks, 4 weeks, 5 weeks, 6 weeks, 7 weeks. Now our Y value is the amount of money we owe. So we're going to be decreasing, right? Because the more the weeks pass, the less we owe. So I need to at least get up to 600. So I think if I go up by every 2 is 100, that might work. So 1, 2, 3, 4, 5, 6. Look at that. So this is 100, 200, 300, 400, 500, 600. And this is amount owed. So after 0 weeks, we're obviously still owing $600. Okay. And then after the first week, we have dropped $40. Okay. So we are going to be, this would be about 550. Okay. So we're going to be a little bit above that, about right there. Okay. After 2 weeks, I wrote that in the wrong spot. I would be right here. After about 2 more weeks, remember we figured that out. That was owing $520. So we're going to owe about $520, which is going to be found right about there. Okay. After 3 weeks, well, we would owe about $480. After 4 weeks, 480 minus 40 is 440. Okay, and then we're going to continue. So notice this is a straight line. So we're going to continue on like this forever. I should have drew this a lot bigger, right? So we should have extended it because this only shows after 7 weeks there. So there's our graph. We should always give a title. So what is this title? This is the amount owed after weeks. Okay, so this is in weeks, this is the amount owed, and it's measured in dollars. Okay, now the question here is, what is the slope of a line and what does it represent? Well, we could figure out slope here. Remember, slope equals y2 minus y1 over x2 minus x1. So let's choose some points on the graph here. Okay, you would have been hopefully writing these down, like this point here. That is 1. Okay, so x is 1, and y would be 560. Okay, because 600 minus 40 after the first week, so that's $560 there. So we could actually use this point as well. This point's really easy to use. You want to use easy points in order to figure out slope. This would be 0 and 600. So let's use these points to our advantage. Okay, I'm going to say that this is x1, y1, and this guy here is x2, y2. y2 is 560. y1 is 600. x2 is 1. x1 is 0. 560 minus 60 is negative 40. 1 minus 0 is 1. Now, so that's what the slope is. It's negative 40 over 1. But remember that these guys have units. What's the top units of it? It's y values. What's the y values units? It's money. So this is negative $40 per, what was our x? It was in weeks, per 1 week. So this is, we lose negative $40 every week. Well, didn't we see that somewhere? That is in our equation here. Negative 40 over 1 week. This equation, P equals 600 minus $40 per week, is actually this graph here, which is kind of neat, okay? So in order to figure out what these slopes represent, ask yourself, what is the fractions here? Figure out slope and then apply the units. Whatever the y units are, that's your top value units. Whatever your x value units are, that's your bottom units. Okay? So again, we still want to be able to use our ratios to determine certain things. We want to use our fractions, okay? And being able to calculate using cross multiplication and division here. Okay, so let's look at this guy here. So Tom is a long haul truck driver. On the first leg of his trip, his current trip, he traveled 380 kilometers in 5 hours. If he drove at a constant speed, what is his rate of travel? Okay, well, we know, remember, rate of travel, we simply just want to figure out how much per hour, okay, or how much per one thing. So that's what rate of whatever, how much per one thing. So here we know that he goes 380 kilometers, okay, for every 5 hours. So that's 5 hours. We want this per 1 hour. That's more useful to us. So remember, this is simply representing a fraction, which is a division. So 380 divided by 5, and that's going to give me 76. And remember, this is now kilometers per 1 hour. Another way to think about it is you're dividing both of these things by 5. 380 divided by 5 is 76. 5 divided by 5 is 1. So that is the rate. He's going 76 kilometers per hour. So hopefully he's not on a 50 kilometer per hour road, or else he is speeding. Okay. After the 5th hour, he sped up. After 9 hours, he had traveled a total of 764 kilometers. What was his average rate of travel after he sped up? Okay, so here, he's traveled for 9 hours now. Okay, after 9 hours, he's traveled a total of 764 kilometers. This just means he sped up. So the average rate of travel is now, what did he travel average over the entire span of his trip? The entire span of his trip, he's traveled 764 kilometers, and his entire trip has taken 9 hours. So here, we will do 764 kilometers divided by 9 hours. And remember, whenever we're finding the rate of something, we want that bottom number to be 1. So I'm going to divide this by 9 and divide this by 9. 764 divided by 9 gives me 96 kilometers. 9 divided by 9 gives me 1 hour. So there's my rate. Every hour he travels 96 kilometers. Okay. So here's where we can use some cross multiplication and division, because we're being given a rate. Okay, so Miriam is reading a book at a rate of 0.6 pages per minute. How long will it take her to read the entire 321-page book? So this is a rate. Always try and figure out what your rates are and what they mean. This is 0.6 pages per 1 minute. Okay, here we can say, okay, I'm always going to put pages on the top and minutes on the bottom. That's the important thing you really want to understand here, is that whenever you have a rate, you can always perform cross multiplication and division to figure some stuff out. So here, 321 pages dividing the X amount of minutes. Now we're going to perform cross multiplication and division. 321 times 1 divided by 0.6. So 321 times 1 divided by 0.6, and that gives me 535 minutes. And I would just leave it like that. Okay, so 535 minutes. Now, in order to use this cross multiplication and division, remember, this is a rate. This is not a ratio. A ratio is when you have the same units on the top and the bottom. You're not going to be able to have the same units here. Since we have different things, this is known as a rate. So in order to use cross multiplication and division, we need the bottom numbers to have the same units and the top numbers to have the same units. This next section, it says, after 2 hours, how many pages will she have read? Remember, we still have this rate per 1 minute. So 0.6 pages per 1 minute. But the time she is reading in is in hours. So we need to convert this into minutes in order to use cross multiplication here. So that won't be super hard because we know that there's 60 minutes in 1 hour. Well, there is another ratio we can use, right? That's 60 minutes per 1 hour. And now I'm going to put hours on the bottom. So 2 hours. How many minutes is that? Cross multiply divide. 2 times 60 divided by 1. 2 times 60 gives me 180 divided by 1 gives me 180. So this will be 180 minutes equals X. So that means we want to figure out how many pages can we read in 180 minutes. So that will be, let's maybe not put X here. We're going to put a question mark. Okay. So cross multiply divide. Multiply the numbers across from each other. So 0.6 times 180 divided by 1. Okay. 0.6 times 180 divided by 1. That gives me 108 pages. Oh, wow, that was bad math. See, that's why you always use your calculator. 60 times 2 is not 180, it's 120. Okay, so that's 120. So that means this should have been 120. Okay. So 120 times 0.6. Sorry, guys, divided by 1. 120, or 0.6 times 120. So that gives me 72 pages. Okay. Remember, we're not talking about ratios anymore. Ratios is when these two things have the same units. When you're talking about a rate, these two things have different units. Okay. We're reading 0.6 pages per 1 minute. In order to use this, we need the bottom values to have the same units, top values to have the same units. Okay. I'm just trying to see here what else we got. Got a few more to go through, which is okay. About 3 more pages. I'm going to do A with you, and I'm going to have you guys do B on your own. If you have questions, please come ask. A line on the graph has the following points. Calculate the slope of the line. So these are coordinate points. Remember, notate these. I'm going to say this is x1 and y1. This is x2, y2. So now we're just going to use our slope formula. y2 minus y1 over x2 minus x1. What is y2? y2 is 0. So 0 minus, what was y1? 204. Over x2, which is 0 again, minus x1, which was 4. Use your calculator, guys. So 0 minus 204. That gives me negative 204 over 0 minus 4. Gives me negative 4. Now look, you have a negative dividing a negative. A negative dividing a negative leaves a positive. So these cancel each other out. So this is 204/4. So you have a positive slope there. Recognize this has a negative slope. So when you do this one, make sure you're plugging it into your calculator and deciding which one's y1, which one's y2, x2, x1, plug it in, use your calculator. Okay. So I'm going to do A here, and then you're going to do B. Okay, so homework. So draw a solid line on the graph that passes through point 0, 0 and has a slope of 5/4. So here, locate where 0, 0 is. 0, 0 is the origin point right there. Okay, it wants us to have a slope of 5/4. We've already kind of done a question like this, right? This is saying slope, which is rise over run, equals 5/4. Remember, our rise is our y, our run is our x. So here, our rise being 5, we have, and it's positive. Both numbers are positive. So our rise is up and our run is to the right. We're rising up 5 units, and every 5 units we rise up, we go 4 units to the right. So 1, 2, 3, 4, 5. Now we go 4 units to the right. 1, 2, 3, 4. So our next point would be here, and now we can connect those points. When you do this, I'll start you off on B. Okay. Locate where 2 and 1 is. 2, this is the x value, this is the y value. X at 2, y at 1, so you start here. Now, starting there, remember, these are both positive values. You're going to go up 2, to the right 3, draw where that new coordinate point is, and connect those 2 points. Okay, so try this one out on your own. Okay, let's look at number 3 here. So Henrik earns $73.20 in 6 hours in his weekend job. Javier earns $550 in 5 hours. Calculate their earnings for 5 different lengths of time. Okay, so here we can figure out a rate. This guy earns, well, let's do Henrik here. Henrik earns $73.20 over 6 hours. If we want a rate, we can do dividing 6, and then figure out 73.2 divided by 6 gives me $12.2. 6 divided by 6 gives me 1, so that's 1 hour. So every hour this guy's going to make $12.2. Okay. Javier here, you would do the exact same thing. We can figure out a rate and use that. This guy earns $55.50 in 5 hours. We want it as a rate, so that bottom number has to be a 1. 55.5 divided by 5 gives me $11.1. 5 divided by 5 gives me 1 hour. So 11.1 divided by 1 hour. Now, we can now simply just go up by 12.2. So after the second hour here, if we know he makes $12.2 per hour, we can just add on 12.2, and this represents 2 hours. The first hour he makes this, the second hour he makes this. So he makes $24.40 in 2 hours. Same thing here. This guy makes $11.1 per hour. Well, 2 hours, we could calculate pretty simply by doing 11.1 plus 11.1. First hour he gets paid this, second hour he gets paid this. So in total he makes $22.2. Okay, and we could just keep doing that for 5 different units of time. We've calculated 4 here technically. Okay. On the same graph, draw a solid line indicating earnings and dotted line showing Javeer's earning. I want you to try out B on your own. Okay, we've done a similar question like this that you might be able to use the understanding above. And also these examples can help you as well. Okay, so something like this might help. Or our example we did way up here, this guy will help as well. That was example 5 here. Okay. So let's do one more together, and then the rest will be on your own. On a bicycle trip, Rita cycled 40 kilometers in 2 hours and 15 minutes and 75 kilometers in 4 hours. What was her average rate of travel between the 2 points? Okay, so we have lots going on here. We have her riding in 2 hours and 15 minutes and 4 hours. So remember, average rate, okay, that's going to be the total distance dividing the total time. Okay, the time has to be in the same units. So the total distance here, well, she rode 40 for 2.25 hours and then 75 kilometers for 4 hours. So that's going to be 40 kilometers plus 75 kilometers. What's the total time here? Well, here, you might know that have you guys ever heard of 2:15? That's 15 minutes after 2. So this is a quarter, which is 0.25, right? 15 minutes equals 0.25 hours. You could also figure out a ratio here. If we want to convert this into hours, it's not super hard because we know 60 minutes are in 1 hour. Now you have an awesome rate here. We can use this rate. We're going to put minutes on the top, so 15 minutes here, x on the bottom. You would cross multiply divide, 15 times 1 divided by 60, and you're going to figure out that x equals 0.25 hours. Okay, so this is 40 kilometers in 2.25 hours. Okay. It's the total time though, 2.25 hours plus 4 hours. 2.25 hours plus 4 hours. Now we can add everything up here. So that will be 40 plus 75. So that's 115 kilometers divided by 2.25 plus 4, which is 6.25 hours. And now we want it as a rate, so that bottom number has to be a 1. So we're going to divide both values by 6.25. So 115 divided by 6.25 gives me 18.4 kilometers. Okay. And 6.25 divided by 6.25, well, that gives me 1 hour. Now let me just make sure all my math makes sense here. 40 plus 75 gives me 115. 2.60 divided by 15. Divided by 60 gives me 0.25. Yep. So everything is looking good here. Okay, so it would be 18.4 kilometers per hour. It looks like they rounded it up, okay, but we would use it as 18.4 kilometers per hour. Now, if after 4 hours she continues traveling at the same rate, how far will she have traveled after 6 hours? Okay, well here we can use our rate here. So she's traveling 6 hours at this rate. So remember, this is 18.4 kilometers, okay, per 1 hour. Now we have this ratio. I'm going to put hours on the bottom. So 6 hours for every, how many kilometers does she go there? Cross multiply, divide. 6 hours times 18.4 kilometers divided by 1 hour. So that will be 6 times 18.4 divided by 1. And that's going to give us 110.4 kilometers. Now you might be asking yourself, hey, it's a little different here. It's because they use 20 kilometers per hour, but we're going to use the more accurate solution here. So they have she traveled in 6 hours going at this rate, 110.4 kilometers. Okay, so that's pretty much the whole unit. You should be able to now answer 7 on your own. So do all these questions that are remaining to complete here. So you have a bit of homework to do. B, make sure you try them out on your own. And of course, if you need help, you are more than welcome to email me or come in and get some answers and some solutions together. Thanks for watching. Have a good day.